I just think that when you look at the math and you look at the reality of what we have to do, carbon capture just becomes essential to avoiding the worst aspects of climate change and to doing those reductions in an affordable manner.
This is EnergyCast, and I'm Jay Downhauer. Today we are talking dollars and cents energy policy from the environmentalist point of view. And if you want to skip the monologue and head straight to the interview, that begins at the 4:10 mark. I've tried hard to keep this program about smart energy technologies, not climate change. But our guest today demonstrates that in order to address carbon emissions, you need to develop these technologies, and they need to make financial sense. I've been saying this for years. Energy policy requires an all-of-the-above strategy, and I would also add that means deploying the best versions of these various forms of energy. That's why I've worked on carbon capture in the coal sector. I've worked on water recycling technologies for the fracking industry. I'm all about taking these great forms of energy and developing ways to eliminate their biggest negatives. And those innovations are the stories I find most compelling when it comes to this program. So when it comes to the environmental community, I can't understand why so many groups can't support nuclear. It makes no sense that many groups are vocally against carbon capture when they are so adamant about climate change. The developing world has mountains of dirty coal underneath its feet. They're going to use it, so it's in our interest to ensure it's used without runaway carbon emissions. Before today's interview was recorded, I was reminded of a scene I saw a few years ago on the HBO series The Newsroom. In one episode, one of the junior producers nabs an exclusive with an EPA bureaucrat who's just written an alarming report on carbon emissions. It's a bit of a long clip, so bear with me.
And joining us now in studio is Richard Westbrook, Deputy Assistant Administrator of the EPA. Welcome.
Thank you.
Tell us about the findings in the report that was just released.
The latest measurements taken at Mauna Loa in Hawaii indicate a CO2 level of 400 parts per million.
Just so we know what we're talking about, if you were a doctor and we were the patient, what's your prognosis? 1,000 years, 2,000 years?
A person has already been born who will die due to catastrophic failure of the planet.
What did he just say?
Okay, can you expand on that?
Sure. The last time there was this much CO2 in the air, the oceans were 80 feet higher than they are now.
So what can we do to reverse this?
Oh, there's a lot we could do.
Good.
If it were 20 years ago or even 10 years ago, but now, no.
You sound like you're saying it's hopeless.
Yeah.
Let's see if we can't find a better spin. People are starting their weekends. Can you give us a reason to be optimistic?
Well, that's the thing, Will. Americans are optimistic by nature. And if we face this problem head on, if we listen to our best scientists and act decisively and passionately, I still don't see any way we can survive.
Okay, Richard Westbrook.
Depending on how you feel about climate change, that was either absurdly funny or deathly frightening. But I would offer up this analogy. When it comes to climate change, there's the chicken and the ostrich. The chickens, more precisely chicken littles, are a lot like that EPA bureaucrat. It's hopeless, humanity is doomed, the only solutions we have are to shut down all industry, sterilize the population, and pray for mercy. Then there are the ostriches. Those are the folks who think that carbon emissions are a non-issue, humanity will move on, and Mother Earth will cope. It's pretty safe to say that we all find ourselves somewhere in between those two birds, and it's been part of my journey on this program to determine where I fall on that scale. Our guest today is John Thompson, Director of the Coal Transition Project at the Clean Air Task Force and Environmental Group. First of all, John is definitely not against ending coal. He believes in its future, which was refreshing when I first met him in 2008 while I was working for the Clean Coal Technology Foundation of Texas. But John wants to see coal and other fossil fuels fitted with carbon capture technology ASAP. And that's where his organization and my foundation saw eye to eye. John has been overwhelmingly supportive of carbon capture's potential, even when faced with setbacks. For instance, the high-profile Kemper County Energy Facility in Mississippi has been hit with a number of budget and schedule setbacks. But John came out in defense of that project recently on NPR and pointed out that the plant's problems were not the carbon capture technology. He'll explain in more detail. It's been about 8 years since I had talked to John, but he's still going strong with the Clean Air Task Force. He still lives with his family in Southern Illinois, and he's still as accessible, forthcoming, and eloquent as ever. I hope you enjoy my conversation with John Thompson. John Thompson, head of the Fossil Transition Project at Clean Air Task Force. John, tell people what that is, what that means.
Our organization is a nonprofit environmental group, and we work on really climate issues as our main focus. We work to avert the worst aspects of climate change, and we do that by really pursuing a number of things. The work I deal with is aimed at moving fossil energy to more of a decarbonized use. A lot of carbon capture and storage, dealing with not just coal, but natural gas, biofuels, petroleum coke, and not just in North America, but also in China. So we kind of work where the CO2 is.
So it's not necessarily transitioning away from these energy sources, as some people might assume. It's transitioning them away from carbon, right?
Right. And I think that's kind of one of the defining features of the Clean Air Task Force. We are very science and economic driven. And since our interest is preventing climate change, we apply both of those. The reality is we just don't see fossil fuels disappearing on a global scale fast enough to prevent climate change. And so we're interested in promoting technologies that can be applied to them, like carbon capture, and keep the carbon from reaching the atmosphere. So while some groups are focused on sort of a leave it in the ground, we're trying to keep it out of the air.
And John, I'm always interested to hear what drove people to certain profession. I don't think we've ever talked about this. What drove you to the environmental community? Was there any particular event in your life?
Yes, in fact, I was an undergraduate at the University of Illinois, and I was studying chemical engineering. And at the time, the university was converting its natural gas power plant to burn coal. And at the time, natural gas prices had risen, and they wanted to save money by converting it to coal. But they were not going to put scrubbers on to address the sulfur dioxide. And I began a several-year effort with some university faculty that convinced the state of Illinois to put sulfur dioxide scrubbers on that power plant. And what we found in that process was that the plant wasn't required to have scrubbers, that the air pollution from that plant would be very large because it was going to be a high sulfur coal. And because the plume of the smokestack didn't rise very much, it was basically going to lead to pretty high levels of sulfur emissions in the local community. And the governor at the time agreed, and it became part of a clean coal demonstration program that impacted several campuses across Illinois and got me started on being an environmentalist. We did a lot of the usual stuff, the demonstrations, the letter writing, the research, that kind of advocacy. So when I finished my chemical engineering degree, I initially went into industry, but found that this is what my calling was. And I've basically been doing environmental work in the nonprofit area for the last several decades.
We're not going to say exactly how. Philosophically speaking, John, what is the environmental community's role?
Well, I think the environmental community's role is really trying to stop pollution and to preserve ecosystems that harm species on the earth. I think if you look over the last several decades at least, the kinds of challenges that we're confronting are things like mass extinctions of species, deforestation across the globe, urbanization, carbon dioxide emission rise, sea level rise, those sorts of things all are sort of central. And if you kind of go back with the conservation environmental movement starting really around the time of Teddy Roosevelt, around the 1900s, and moving forward through Rachel Carson in the 1960s, and really the global warming concerns of today, I think there's been sort of a common set of themes. It's trying to set aside natural areas to be preserved in their pristine state to preserve endangered species, to limit pollution, and to find ways of doing this that still allow us as a society to grow and thrive.
You mentioned Teddy Roosevelt. Do you think that environmentalism is only a cause of the political left? It would seem that those political lines are blurring more than they have in the past. What's your thoughts on that?
Well, I think over time, the environmental cause has traditionally been nonpartisan, at least in the United States. And I think that there are some parts of it, like the conservation movement, that I think traditionally appealed more to Republicans, and there might have been more pollution kinds of things that might have appealed more to Democrats. But I think it's an interesting question that I don't know what the future holds. I think the United States is becoming more partisan, and I think the environmental movement is in danger of being a victim of that partisanship. And the problem, of course, in my view with that is that we're always going to be changing political parties in this country, and you don't ever want to have your cause purely associated with one or the other, because parties change and power changes in Washington, then your agenda can come to a grinding halt.
I think one of the biggest criticisms about environmental groups is, this is a common criticism I heard, was that they are the enemy of economic progress. The industry must suffer for environmentalism to gain. But I don't think that's the position of the Clean Air Task Force.
Yeah, I don't think it's our position. And, honestly, I don't think it's really the position of most industries. I think if you talk to oil companies, if you talk to chemical manufacturers, if you talk to a wide range of large corporations, they sort of see the benefits of well-designed regulation. And I would say that the way that we see the world, and literally the world, because we work in China, we work in the United States, we work in Europe, it's that we have to find ways that address the basic science problems that are defining the environmental challenges as well as the economic ones. Because human nature, and it doesn't really matter where you are in the world or what your political persuasion is, that if you can't find ways of solving the problem economically, it's not going to be implemented. At least it won't be a durable solution. And so that's why we focus a lot, not just on coming up with good regulations, but also promoting new technologies. We are interested in coming up with ways that reduce carbon dioxide in the case of climate change, but also do it at the least possible economic impact.
One of the reasons that we came together was that you were in support, and Clean Air Task Force still remains in support of clean coal technology. Tell us a little bit about that.
Well, first of all, I guess I should say I've come to believe that the term clean coal doesn't really advance discussions, because I think what happens is that people on both sides of the spectrum tend to react to it in different ways. I look at it this way. I'm in favor of carbon capture.
Sure.
And finding ways of capturing carbon and finding ways of storing it deep underground so that it can't reach the atmosphere. So if you kind of look as a pragmatist as to where that carbon comes from around the world, coal is a dominant source. Oil is a dominant source. Natural gas is a dominant source. And there's a lot of different ways of measuring it, but it's really where most of our energy comes from across the world. So we've got to find ways, in my view, of capturing that CO2. Now, what I see as the value of carbon capture is that I think a lot of people tend to focus only on the electric sector, but really the industrial sector and transportation sectors are pretty huge. And carbon capture and storage is a technology that works on a lot of those sectors. The idea is that with carbon capture and storage is there's three different complementary technologies that work to isolate that from reaching the atmosphere. If you were just to rank all the countries and their CO2 emissions across the world, China would be number one, we would be number two, and India would be third. If you just took the industrial emissions from China and they were their own country, alone would be ranked number three. If you took just the industrial emissions from the United States and put them in their own country, it would rank sixth among nations. This is a huge, huge segment, and for the most part can't be addressed absent anything but CCS. So while I focus on coal, while I focus on natural gas, most people tend to think of those as a power sector issue. What I would just say is that it's not just a power sector problem. It's also critical for dealing with industrial emissions too.
That's a great point, that it's not always utilities and electricity production that's the reason for emissions. Getting back to power plants, there were two carbon capture projects in Texas that were announced back last decade that didn't work out. But there's still the Mississippi Power project that has had some challenging overruns, but it's still in the game. You were quick to point out in an NPR story last month that the problem with that was not necessarily the carbon capture technology. Can you tell us a little bit more about what your point was in that?
Sure. The Kemper project has been in the headlines a lot, and one that I talked about on All Things Considered the other week. This is a plant that started construction around 2010 or 2011. It's over budget. It was originally going to cost somewhere in $2.5 billion or some odd dollars, including the mine, including some other things. That cost is a little above $7 billion today. And it's been delayed. It's been only recently, or just only now, about to begin commercial operation. And so I think there's a lot of folks who look at that and say, well, this shows that carbon capture doesn't work, because otherwise, this is a huge overrun. My point is simply this, that if you actually look at that plant, it's a demonstration of a new coal gasification technology called the trig gasifier. This is the first large-scale application of it. It's a 582 megawatt plant. Its next biggest size was when it was demonstrated at 6 megawatts thermal. So it made this jump, and I think that that's most of the cost overruns. The capture unit for the carbon dioxide on that is actually a very mature technology. It's called Selexol, and it's been in commercial operation in industry around the world since about 1960. And there are literally hundreds of Selexol units. And that mature technology is not the source of the cost overruns at the Kemper plant. It's really the marriage of this new coal gasification technology to this mature carbon capture technology. The cost overruns are not really related to, in my view, the capture unit. It's the scale-up issues that they've had in being the very first plant to use this gasification technology.
Yeah, so I think the point here is most definitely don't give up on it just yet, that the capture technology is there. It was the other things that were really causing a lot of the budget issues. Yeah.
Well, yeah, and I think there's kind of a general fuzziness in the public about what these costs really are. Mm-hmm. One of the best ways to measure cost is the avoided cost of carbon. So if you've got a source and you remove the CO2 through some means, could be replacing it with a windmill or a nuclear power plant or adding carbon capture and storage to it. One way is to figure out on a dollar per ton basis what the cost of capturing that is, or the avoided cost of taking that CO2 out. And avoided costs are not just the cost of reducing the CO2, but also providing that replacement power that would have been done with the energy that was used for capturing. And if you kind of look at that dollar per ton on avoided cost, basically there's not much difference between carbon capture and storage and nuclear and renewables. They all kind of come in about the same level. I think we've made really good progress on renewables in this country over the last 20 years because we've put in place the kind of incentives that drive windmills and solar plants. We provide investment tax credits. We provide production tax credits. We provide requirements in state laws for minimum amounts of renewables that have to be part of the electric system. We've not done that yet with carbon capture. We need to do that. Study after study comes to some basic conclusions. One is that if you are going to live in a world that constrains carbon dioxide, carbon capture is a fundamental technology for keeping the cost down for that total reduction of CO2 that's necessary.
What is Clean Air Task Force's view on natural gas, and I would say specifically fracking that's emerged in the last several years?
When it comes to fuels, we're agnostic. We're interested in reducing pollution. So when it comes to fracking, we sort of take a pragmatist view on it, which is that it's happening, so we need to find a way to do it responsibly to minimize the impacts on the environment, both during the production of the natural gas, but also as it's being used, reducing methane leaks, reducing the threats of groundwater contamination, reducing the threats of seismic activity as the brines are reinjected into the subsurface. And we've worked collaboratively with other environmental groups in industry, trying to come up with what we consider to be a template of the kind of regulations that would set a standard for doing the job right. And then at that point, let the market decide what's the fuel of choice.
John, I'm always puzzled by this. Why do you think that some environmental groups are supportive of nuclear and some are not?
I think there's good debates on both sides of this. On the one hand, there are groups that support nuclear power, and we have a program that tries to promote next generation nuclear technology. So we're in that camp of trying to find ways of making nuclear work. And I think that for us, it comes down to the math. The world population is likely to increase significantly over the coming decades. So that means probably more energy, and that if we want to meet our climate goals, it means we have to have clean energy. So one of the advantages of nuclear power is it's scalable. It's one of those technologies that can be built quickly. The problem, of course, are dealing with waste, dealing with issues like proliferation of material so that it doesn't end up in the wrong hands and destabilize security of the planet. And so one of the ways that we approach that issue is to try to promote technologies that don't produce bomb-grade materials or that don't produce wastes in a form that has to be managed over geologic time. And I think that there's a healthy debate on all sides of this, and we respect people on both sides of this issue.
Let's get a little bit deeper into climate change, and I've tried not to make this an energy program about climate change as much as some others have. But I think the biggest question I have is, yes, CO2 concentration is rising. Yes, weather patterns would indicate an upward or irregular trend in the climate. But the big question I have is, John, how much mitigation is enough mitigation? Is there any consensus on that?
Well, this is a big topic.
Yeah.
First of all, I would say that there's a lot of division. There are groups that say we just don't believe in the science of climate change, and I'd have to say to those groups, the science is pretty firm. But I think that more fundamentally, when I deal with people who are concerned about taking climate action, it's that they are concerned about the cost. And so I think of what I would call certain conservatives and certain conservative groups who really don't have a problem so much with the science of climate. They get it that the basics is pretty simple. It's a thermometer, and you can measure those readings. And since 1880, the global rise in temperature is about 1.7 degrees Fahrenheit. They look at the ice sheets, they see them melting. They understand the ocean rise. They understand the acidification of the oceans. They understand the latent heat that's being stored in the oceans. But where they get stuck is, I think, at a healthy point, which is, can we affordably address the mitigation? And I think that is kind of tied into your question to me, which is how much mitigation is enough. I think that if you look at the climate models, they suggest that by the end of this century, we have to phase out basically all the CO2 emissions from the planet. And we have to decarbonize the entire electric system by about 2050. That's a pretty deep reduction. And the cost of doing that with today's technologies, I think for some people, they just say, I'm uncomfortable with that cost, or I'm uncomfortable with the prescription that it's all has to be done with one kind of solution or none at all. And I think that's where we really need to focus on the productive dialogue. I think that the best solutions usually come about when people set aside preconditions. There are many who might say, I'm skeptical about today's technologies. And to that group, I would say, well, you have good reason. Let's invest in new technologies and developing new technologies that can lower the cost. I think that there's also wide appeal for incentives. I think where there's disagreement is often over regulation. I happen to be a firm believer that regulations are critical to advancing progress, and that the reason our air is clean and clear in the United States is that we have those regulations, whereas the reason China's air is dirty and often visibility is a block or two is they don't have them in a functional way.
I sent you that clip last night. It was an episode of the TV show The Newsroom in which an EPA bureaucrat says, metaphorically, the house is already burned to the ground. It's too late to call the fire department when it comes to climate change. Is it too late?
First of all, every problem that we face always seems at one point or another to be too late. But I think that when you kind of peel away the layers, we have no choice but to keep moving towards those solutions. The thing that's true about climate change, the longer we wait, the more expensive and the fewer options we have in implementing change. I remain an optimist about this, and I thought the newsroom clip was interesting, but it's drama. It's written to be dramatic.
I think it's written, for humor.
Humor or attention grabbing or whatever, but I think that it did touch on some fundamental topics, and I think you decide to that you're going to work on the environment, which I have for decades, you kind of have to just put that pessimism to some degree on the shelf, because otherwise you can't keep going at it day after day. But if you look at over the long arc of history, I do believe that we're getting smarter. Our technology is getting better. Our systems of deciding things on the whole are getting better. And so I have to think that even though climate change is perhaps more challenging to overcome even than poverty, that we will find ways of dealing with that. And I suspect that if you and I look back on this interview 20 years from now, we'll find that a lot of the things that we were concerned about did come to pass and that we were right about some things. But in all likelihood, we'll probably talk about technologies that we didn't know were even possible have emerged in very quick time.
I wanted to ask a little bit about Clean Air Task Force as an organization, and how is Clean Air Task Force funded year after year?
Most of our funding comes from grants from private foundations. The Hewlett Foundation does a lot of the work that I'm associated with right now. Then we also get money from individual donors. We don't accept money from industry, and very, very rarely do we take money from government. This allows us, in our view, to kind of focus on what we really think to be what's the best science, the best economics that can drive our decision making. We operate on a budget of about $5 to $7 million per year, and that's probably spread over 20 to 30 people. And then we hire a lot of consultants and things like that.
The reason I was asking is the private donation part. Has that ever been an issue where a private donor, for instance, would come to you and say, look, I want to give you guys money, but, your stance on nuclear, I don't really see eye to eye on that. Have you ever had conflicts like that where maybe some of your donors had some disagreement maybe with Clean Air Task Force's philosophy?
I wish we had the problem with individual donors coming to us and waving checkbooks in front of us. It usually is the other way around. We have to go out and find them and convince them that they should open their checkbook to us. And because of that, then we're able to screen to avoid conflicts.
Okay. John, that wraps the normal round of questions. I'm going to finish up with the lightning round of your thoughts on different energy technologies. So just real quick answer. So your thoughts on natural gas?
Half the CO2 emissions of coal, but still require carbon capture in order to zero out emissions that are required to avert the worst aspects of climate change.
Crude oil.
It's going to be with us for a long time. We have to find different ways of providing liquid transport that can take its place. That could be ammonia, it could be hydrogen, or it could be batteries.
Nuclear.
I think nuclear is challenged right now. I think there are emerging technologies that show a real positive role for it in the future.
Coal.
The dominant fuel source in the world. And if we don't come up with a solution for coal's emissions, particularly in China, if we don't budge the dial in China and their coal use through carbon capture, I don't see much hope for averting climate change.
Wind.
Intermittent. We'll need to figure out ways of storing energy from wind and find ways of transmitting it when the wind doesn't blow by bringing in wind from other places.
Solar.
Same challenges of wind as intermittency, but it has some storage options that allow it to extend into the night.
Biofuels.
Challenge there is finding the feedstocks that actually result in net carbon emissions.
Fuel cells.
An interesting technology, one that we're very interested in promoting.
Hydroelectric.
Limited expansion capabilities beyond what we've got.
Geothermal.
A lot of interesting breakthrough technologies that could change the way geothermal works over the coming decades.
Electric vehicles.
Expensive, but with hope, we may find ways of bringing their costs down to the point that they're affordable absent subsidies.
And finally, nuclear fusion.
An interesting technology that has been on the horizon for decades. There's some interesting work being done that might accelerate that, but it's sort of that holy grail, and we'll see if it can emerge.
John Thompson, Clean Air Task Force, thank you so much for your time.
Thank you.
That was John Thompson, director of the Coal Transition Project for Clean Air Task Force Environmental Group. During the interview, John also reminded me about the Petronova project, a successful carbon capture venture between NRG and JX Nippon Oil and Gas Exploration near Houston. The facility captures about 90% of carbon emissions from a 240 megawatt facility. That works out to about 1.6 million tons of CO2 a year. It has been running since 2016, unlike the Kemper project we discussed. Petra Nova was built onto an existing coal facility, so there were a lot fewer moving parts. And you also heard John talk about the task force's policy of not taking money from industry. Last time we saw each other was over lunch at Three Forks Grill in Austin. We split an $11 plate of fish tacos and later had to work off the check with the waiter so that my industry association was not paying for his meal. They really stay true to their word. All guests on this podcast are sent the raw and complete versions the week of release to ensure they have been fairly represented. So far, no complaints. Music was produced by Sean Stroop at Stroop Loops. You can find us at Host Energy on Instagram and online at energy-cast.com. That wraps up episode 15. Be sure to join us next week when we discuss a smaller, more modular future for nuclear power. Until then, I'm Jay Dowenhauer. We'll see you next time.